Welcome back. While one-dimensional arrays are useful, the true power of NumPy lies in its ability to efficiently handle multidimensional arrays, most commonly two-dimensional arrays, or matrices. This lecture will show you how to index and slice these higher-dimensional structures. 1. Creating 2D arrays. A 2D array is typically created from a list of lists, where each inner list represents a row. We call this structure a matrix. The order of dimensions is important. Rows come first, then columns. The .ndim attribute confirms the number of dimensions, which is 2 for a matrix. Two, indexing 2D arrays. To access a single element, you use a single pair of square brackets, containing the row index and the column index, separated by a comma. This is the preferred way. Matrix square bracket row index, comma, column index square bracket. If you only provide the first index, NumPy returns the entire corresponding row. 3. Slicing 2D arrays. Slicing works by applying slicing notation to both the row and column dimensions, separated by a comma. The colon alone acts as a wildcard, selecting everything in that dimension. In the first example, we select rows up to index 2 and all columns. In the second, we select all rows and only the column at index 1. Remember, all these slicing operations also create views, sharing memory with the original matrix. To summarize, mastering comma-separated indexing and slicing is vital for manipulating matrices in data science. Our next lecture 35.10. Few more attributes. See you there.